Hello again. Chapter 1, Section 3, pages 18 through 22 in the text. Scientific inquiry. Inquiry, as defined in the dictionary, is a request for information or the act of asking questions in order to gather information. Now, scientific inquiry is how scientists ask these questions. They ask the questions based on observations they make. Remember, observations are anything you see, hear, touch, taste, or feel. You use your senses to gather observations. After you've gathered observations, a question might come to mind. For example, when it's cold outside, you might hear the crickets chirp. A question that might be posed is this: when it's cold outside, crickets chirp less, but when it's hot outside, crickets chirp more. That would be a question based on your observation, the observation of being cold and the observation of you hearing the crickets chirp. If we wanted to quantify that observation, that would be better. Remember, quantity deals with numbers. So, if we said when it's 66 degrees outside, the crickets will chirp 45 times in 1 minute, that would be a quantifiable question. Much better than a qualitative question. Remember, qualitative, no numbers, quantitative, numbers. After you made your question, you'll need to develop a hypothesis. A hypothesis must be testable. That is important, because if it's not testable, who will know if your question is correct or not? You cannot prove it. So a hypothesis, number one, must be testable. Number two, it must be put in an if-then statement. For example, if we use that cricket analogy again, my hypothesis might be this: if it is 66 degrees outside, then the crickets will chirp 45 times in 1 minute. That's a hypothesis put in an if-then statement. Remember, a hypothesis is an educated guess based on my observations, and it's put in an if-then statement. The third part of the scientific inquiry is designing an experiment. Now, we will spend the bulk of our time talking about designing an experiment. An experiment is done to test your hypothesis, to see if you're correct or not. Now, there's lots of terminology in designing an experiment. Like I said, we're going to be spending class time talking about this. What I need you to do now is to pause the video and read page 20 of the textbook to get an understanding of the vocabulary involved. Things like variables, manipulated variables, responding variables, controlled experiment, controlled, and operational definitions. These terms are confusing. Tonight, read over those definitions, get a little understanding of them. Tomorrow in class, we'll go over them, and over the next couple days, you'll have a good understanding of what each one of those mean. So, third part, designing an experiment made to test your hypothesis. After you've designed an experiment, you will need to collect the data from the experiment. Data are numbers that you collect from your experiment. For example, in our experiment, the data might be something like this. When it's cold, we notice that the crickets chirped 15 times in 13 seconds. However, when it got warmer, the crickets chirped 49 times in 13 seconds. This would be our data, the numbers collected from the experiment. Now, this data can be put in charts or graphs, whatever you feel is necessary. The fifth part of the scientific inquiry is drawing conclusions. This is where you decide, is your hypothesis correct or is your hypothesis incorrect? Correct or incorrect? Is it okay if your hypothesis is incorrect? Of course it is. Scientists get things wrong all the time. All the time. If we got everything right the first time, we would know the answers to everything. We'd have the cure for cancer. We would know everything there is to know. However, because scientists are wrong a lot, there's a lot of questions that still remain. However, What this does is we know next time we do this experiment, we know now to change our hypothesis. We know what not to do. So we did learn something in getting our hypothesis incorrect. 2, 3. Now the sixth part of the scientific method is to communicate your results. Communicating your results is very important. This tells scientists what not to do if you got your hypothesis incorrect, or what to do if you got your hypothesis correct. You guys can communicate your results in journal articles, speeches, or science fair projects. There's many ways you guys can communicate your results. These are the 6 steps of the scientific method. Thank you.